Hello students, good evening all. So welcome to our next session of chapter Indefinite Integrals. So this is our fifth session in this particular topic, Indefinite Integrals. So far we have discussed our methods of integration as well as the basic integrals, standard integrals, some of the standard integrals and all. So we'll just continue the rest in our today's session of indefinite integrals. So before getting into the class, we'll just have a quick overview of what and all concepts that we are going to deal in our today's session of indefinite integrals. So in our today's session of indefinite integrals, we are going to start with the standard integrals. So if you remember, in our previous session, we have seen for corresponding functions, we have seen the standard substitution. Right, so for suppose if we are having root over x square minus a square, the corresponding substitution, like for example, in place of x, what can be substitute? So that corresponding substitutions we have seen. Right, so in our substitution, while we are discussing our method of substitution. Right, so here for this function, what we have to do, we have to substitute our x and then we have to simplify it further and then we have to integrate it to get our final result. Right, so without doing all that huge process, what we can do is we can remember this as in standard integral. Right, so those formulas I'll be giving here in our standard integral so that it will even makes our question to solve within few minutes. Right, so after the standard integrals, we are going to look into the integration of so this is the rational functions which we have already covered. So in this rational functions, we have seen when denominator rationalized, when we can factorize the denominator, where we cannot factorize the denominator. So this rational functions where the denominator is not factorized, we have seen. So that will be something related to our irrational functions. So that's why I have given you here our integration of rational functions. Right. So the next one here, as I mentioned, our rational functions integration is somewhat related to our irrational. So after the integration of rational functions, we are looking to our integration of irrational functions. So basically, what do you mean by irrational functions? So in a simple words, we can take it as when we have a root expression. Right, so in any general manner, in general way, we can say that. Right, so here we are going to look into the integration of a typical square root functions. Right, so after that, we are going to see the irrational algebraic functions, the same thing. So how we will be seeing the functions, how will be whether there is a possibility of factorizing. If it's a factorized, can we have like which formula we can do, which method of integration we can apply here. So that and all we are going to see here. So basically we have already finished our methods of integration, but now we are dealing for certain specific functions how we'll be doing the integration. So we have already discussed for the rational functions. So today in particular we are going to look into our irrational functions, and after the irrational functions we are going to our trigonometric functions. So far we haven't touched basically our typical complete trigonometric functions, right? So how to integrate that. So in today's session, we are going to concentrate in particular for our trigonometric functions also, how we'll be doing, like not in a one specific way of function. So that trigonometric function can have in different types, right? In different ways the function can be. So here in our today's integration of trigonometric functions, we are going to discuss few types of trigonometric functions. So how we are going to integrate those specific types of trigonometric functions. And after the trigonometric functions, last but not the least, we are going to discuss our exponential functions. So how we are going to integrate the exponential functions. So far if you observe, wherever we have discussed our standard integrals, all are related to our either algebraic, either trigonometric, either simple logarithmic, very less, right? So we haven't seen a typical exponential, a complete exponential function, standard integrals and all, right? So here in this integration of exponential functions, even we are going to look into the standard integrals which are related to our exponential functions as well as different types of exponential functions, how we are going to find the integration of it. So overall, in our today's session, we are going to discuss about irrational trigonometric as well as our exponential functions integration. Right, so along with that, for each of the method correspondingly, we are going to solve questions. Right, so let's start with the standard integrals as I mentioned. So here you can look at here. So here the function is 1 by x square plus a square. So the direct integral will be 1 by a tan inverse x by a plus c. Right, so in some cases, after simplifying it, what we can get is, we can expect a function like x minus 5 whole square plus some 3 square. Right, which means if we compare both these expressions here, in place of x, what we are having? In place of x, we are having x minus 5. So now I can use the formula here and this will be turning out to be 1 by 3 because my a here is 3. So 1 by 3 tan inverse. So in place of x, instead of x, I am having here x minus 5. So this will become x minus 5 by 3 plus c. So it's as simple as that. Right. So simply we can see here, we can remember this formula, this integral, and then we can directly apply that. So what's the reason to remember this? Because most of our rational functions or most of our irrational functions, while dealing with it, we mostly get an expression, a function in terms of either x square plus a square, x square minus a square minus x square. So we could actually arrange that in either of these forms, right? So if we could arrange them in this format, so it's easy, right, to remember the formula and directly apply it instead of taking a substitution and then simplify it further, which actually consumes a more time. Right, so that's why I suggest you guys to remember all these formulas which help you to consume your time while doing the questions related to these typical integrals, mostly when we are dealing with integration of rational functions, irrational functions and all. Right, so this is one set of here and the other set you can see here. So root over a square minus x square. So that's what I said. So in our substitution, when we are discussing our method of substitution, so there we have seen only, so integration of root over a square plus a square minus x square. If we are having a function like this, so we'll be directly substituting in place of x a cos theta, and then we are going to substitute here in this given function and we are going to simplify it further. At the end, again, we end up having this function, this expression. So instead of all this doing this substitution, simplification and all, we can directly remember this. So at the beginning, it may feel like to remember these, it will be difficult. But when you are going through it, so it will be easy once you are habituated to it. So please focus on this all standard integrals. They are very, very important. Right. So these are our basic important standard integrals which help us to easily find the integral of our rational functions, irrational functions mostly. Right. So let's get into our irrational functions now. So rational functions we have already covered. So in our previous session. So here, as I mentioned, this part of irrational functions is actually the same how we have done in our rational functions. Right. So for irrational, as I mentioned, we'll be having a square root term here. Yes or no? So here we are having a square root term. Right. So how can we rewrite this? So if my integral is of form integration of dx by root over ax square plus bx plus c. So I can take this inside expression of the square root ax square plus bx plus c. So if you remember yesterday in our previous session, we have seen this where our denominator of a rational function cannot be factorized. So how we have simplified this? So I'll be taking a as overall common. So then it will become x square plus b by ax plus c by a. Right. So then I am going to rewrite this as, so a will be as it is outside. So x plus b by a whole square. So I am going to write it to be x plus b by a whole square. Right. Sorry, b by 2a. It should be 2a, right? So x plus b by 2a whole square. So then what should be subtracted to get this expression? I have to subtract b square by 4a square, and plus constant c by a is already present. So the same thing which we have done in our previous session, if you guys remember, the same expression. So further what we are going to do, so this can be our t. So now I am going to assume x plus b by 2a to be t. Right, so then this will become t, and this according to the sign I am going to assume to be a k square, because it's nothing but a simple constant, right? So it's a constant, it's nothing to do here, so it's a constant k square. So now how my integration will be turn out here? Integration of dx by root over, so in place of x what I can do, so here dx is equal to dt, directly I can substitute dt. So this complete integral will be turning out to be root over t square plus or minus k square. Here a will be there. So as root a is a constant, I can pull out my root a outside. Then my integral will be 1 by root a dt by t square plus or minus k square under root, for my irrational function here. Right. So if you remember, we have taken the same quadratic expression as how we have taken in our previous while we are discussing the rational function, and then we have just simplified and rewrite this so that we could end up getting this. We can reduce that into our standard integral form. So if you remember, it is in the format of integration of 1 by root over x square plus or minus a square. So if we get back to our standard integrals we have seen, so that is in the format of, here you can see 1 by root over x square plus a square, or else 1 by root over x square minus a square. So we can directly remember and we can directly substitute by comparing the two integrals. What is our a and what is our x, we can compare and we can directly apply these two formulas, that is these two standard integrals here. So it's as simple as that. So that's the reason why I have given the list of standard integrals ahead. Right. So this is our irrational function, how to integrate that. So basically here we will be using our standard integrals to simplify our irrational function. Right. So that is of one type. So here the first type of irrational function is of form integration of dx by root over ax square plus bx plus c. So what about the other? So the other is root over px plus q by integration of px plus q by root over ax square plus bx plus c, or else it can be of the form px plus q root over ax square plus bx plus c. Right, so if you remember, even in our rational functions we have a similar expression, a similar integral, where we have seen how to simplify it and how to reduce the integral. Right, so first step will be writing our px plus q as capital A into the differentiation of the denominator. Right, the expression present in the denominator. So we will just neglect the root here. So it will be ax square plus bx plus c and then plus constant b. And you know how to find the standard values a and b. Right, and then we will be substituting it. So these will be coming as two different terms, and then we are going to separate it as two different terms. So one term will be in the format of f dash x by root over f of x, and the other term will be some constant will be there and divided by root over ax square plus bx plus c. Right, so these two terms will be coming when we write our px plus q as a into the differentiation of the denominator expression plus constant b. Right, so if you observe the first expression, so it is in the format of f dash x divided by root over f of x. So what is the integral of it? So it's as simple, directly it will be root over f of x plus c, if you remember the formula. Right, so similarly this is the just type we have seen before. So this can be rewritten as the format of 1 by t square plus or minus a square under root. Right, so we can reduce this, right? So and then we can directly apply the standard integral formula. So that's the whole idea here, to integrate and find the integrals of our corresponding given irrational functions. So I hope you guys got a quick idea, because these are the things we have even discussed in our previous session of rational functions. So the only difference here is, in our previous rational functions, we won't be having the square root, and here we are going to have the square root. And the expressions here, you can see the direct formulas. The expression without square root will also have the formula, that is for our rational functions, and the expression with the square root will also be having the formula here, which is for our irrational functions. So now I hope you guys are clear with this concept of how to find the integration of our irrational function. So let's quickly solve one question. So as we have solved our rational function, so there will be nothing new here. So only the root expression, but for that there is nothing gonna happen. You are just changing the formula itself. So can you guys quickly give it a try and tell me what will be the answer? So you can at least tell me the simplest form first of this integral, and then we can see what is the corresponding formula we are going to apply the later. So come on guys, quickly look into the question and tell me. So first we have to identify in which type it is. So as it's a square root, so we are sure that it's the irrational function. And then we have to check it is in the format of integration of px plus q under root ax square plus bx plus c dx. So it is in the format of type 2 irrational function. So just now we have discussed how to simplify this type 2 irrational function and find the integral of it. So just quickly do it guys. So what will be our first step here? Anyone? See here we are having px plus q. So the first step will be, according to our type 2 irrational functions, we are going to write in place of px plus q, we are going to write it to be a into the differentiation of the denominator expression, that is 5 minus 4x plus x square plus constant b. And here our aim is to find a and b. So in place of px plus q, we are having x plus 3 here. So we have already seen how to find these constant values a and b. So you can quickly find it out and let me know. So if anyone got the values of a and b, can please tell me guys. Okay, Siddharth already given the answer. So what about others guys? Sine inverse x plus 2 by 3 plus constancy. Perfect. So Siddharth has already given. So Siddharth, can you tell me what is the value of a and b here? Constant values a and b. Okay, Arun got it. Okay. So here I'm just trying to find it out. So here x plus 3. Okay, Shyam has given a 1 by 2 and b 5. Can you check? I think it's got wrong. Can you check once? So if we differentiate, so it will be minus 4 plus 2x here and plus b, and we have to simplify it further. So minus 4a plus 2ax plus b. So let's just compare the x coefficients and and constants. So x coefficient here 2a is equal to 1. So yeah, where a will be equal to 1 by 2. Sorry, here it should be minus, right? So it should be plus only, right? So plus 2x minus 4 and plus 2x, perfect. So it will be 1 by 2. And b here will be, after substituting, we can find the b also. What is the second equation? Constants. So minus 4a plus b will be equal to 3, and you can substitute here so that you will be having your b value. Okay. So once we got our a and b value, we can substitute that in this expression and we can substitute our integral. So this will be 1 by 2 and 1. I hope it will be 1 by 2 and 1. Can you guys confirm it? So it should be 1 by 2 and minus 4, 1 by 2 plus b will be equal to 3. So it should be 1 by 2 and b equal to 3 plus 2, 5. It should be 5. So a value will be 1 by 2 and b value will be 5. So these are our two values for a and b, and then we can substitute it here and then we can so a will be 1 by 2 and 5. Okay, correct, Syam. It's okay. So I think there is a sign mistake here. No issues. So what is the numerator that we are going to substitute here? That will be a 1 by 2, right? So it will be 1 by 2 minus 4 plus 2x plus 5. So this is the thing which we are going to substitute. So let me erase this. So now what will be our expression? So minus 1, so it will be 1 by 2, right? So 1 by 2 minus 4 plus 2x plus b 5 and divided by root over 5 minus 4x plus x square. So just now I have solved a and b values, we got it. So a is equal to 1 by 2 and b is equal to 5. So until this, I think it's fine. You can check. So, and then we can, yeah, I'm just solving it. So we can just, now what can we do? We can separate it. So how can we do that? So 1 by 2 is a constant. We can pull it out. So minus 4 plus 2x divided by root over 5 minus 4x plus x square. So this will be one term plus 5. I'm just separating according to the numerator. So 1 by 5 minus 4x plus x square under root. So this is second term, right? So what is the first thing we have done? So we have written it to be px plus q is equal to capital A into differentiation of our denominator plus b, and by simplifying it we end up having a value 1 by 2 and b value 5, right? So further we are just substituting that. So after simplifying we are having this. So if you observe what is our first, so I am going to take this to be my I1. I am going to assume this first term to be I1 and this second term to be I2. So let's find the integral of I1 first. So I1 is nothing but 1 by 2 integration. So this is minus 4 plus 2x. So minus 4 plus 2x is nothing but differentiation of my denominator, the expression which is inside, right? So this is minus 4 plus 2x divided by root over 5 minus 4x plus x square, right? So this is my I1 which I have assumed. So this is my first function. So the integral will be 1 by 2 root over f of x, right? So that is 5 minus 4x plus x square plus constant c. So this is my integral of first one, that is 1 by 2 root over 5 minus 4x plus x square plus constant c. So now we are trying to find the second one. So let's just find the second one. So I'm just erasing it. So my I2 is nothing but 5 integration 1 by root over 5 minus 4x plus x square into dx. So now our aim is we have to rewrite this expression, quadratic expression. So x square minus 4x plus 5. Right, so how can I write? It will be x minus 2 whole square. If I have written it to be x minus 2 whole square, what I have to add? So it will be x square plus 4 minus 4x. So I'm already having this minus 4x here and x square, but there is a extra plus 4 which I have to eliminate. So I am going to subtract minus 4 and plus 5 constant is already there here. So now this entire expression will be turning out to be x minus 2 whole square plus 1. Right. So now this will be 5 integration of 1 divided by x minus 2 whole square plus 1. So 1 square is also fine. Right. So now I am having root over x minus 2 whole square plus 1 square, which is according to our standard integrals which we have seen in our previous set of slide. Right. So this is 1 by root over x square plus a square. So let's get back there and see what is the formula. 1 by root over x square plus a square, that is sin h inverse x by a. Right. So the formula here, sin h inverse x by a, that means, so 5 into sin h inverse. So what is our x here? X minus 2 by a, that is 1 plus constant c2. Right. So now my complete entire integral of this function will be I1 plus I2. Yes or no? So what is my I1? So my I1 integration, I already got it to be 1 by 2 root over 5 minus 4x plus x square, and integration of I2 is nothing but 5 sin h inverse x minus 2 plus overall I am writing c1 plus c2 constantly, combinedly I am writing it to be constant c. So this will be the final answer here. So 1 by 2 root over x square minus 5x plus 5 sin h inverse x minus 2 plus c. Because we have written this quadratic expression in the format of root over x square plus a square. Right. So root over x square plus a square. So you can write in terms of h inverse. If you want, you can even write in terms of log also. There is no issue. So if you want to write in log also, it will be log of x plus root over x square plus a square. So that's the difference. So here I have represented in terms of sin h inverse. So now I hope you guys are clear with this and how to solve these irrational functions as well as how to apply our standard integrals. Right. So if you guys are clear, we can move ahead. Okay. Shivaranjani has also given the answer. Okay. Shivaranjani has written using the logarithmic format. But it's okay. Anything is fine. You can apply even sin h inverse or logarithm according to the formula. No issue there. So any doubts in this question? I hope I have clearly simplified and solved this particular question. If still anyone has any doubts, please let me know, guys. Quickly. Okay, got it. So for this same question, I'm just changing I'm just doing a slight change so that you can give it a try just now and we can make sure that you are clear with it or not. So I'm just changing a slight change for this same question. So x plus 3 divided by 5 minus 4x minus x square. I am just changing the sign here. So integration of x plus 3 by root over 5 minus 4x minus x square. So can you guys solve this and let me know what's the answer, final answer for this question? Quickly. So procedure, the entire procedure will be same. There is nothing new. Just how we have solved for the previous this one. So the entire procedure is same. I have just made a slight change here, sign. So can you simplify this? So due to the slight sign change also, your formulas and everything will be going to change. So can you just simplify this question and let me know what's the answer? Quickly. So the same methodology which we have solved this question. Can you guys quickly give it a try? So whoever solving first, you can let me know what is the A and capital B values so that I can just write down here. And we can be clear with whether it's correct or not, because that's the first step. If we are wrong in the first step itself, then our entire further solution will be getting wrong. Okay, Siddharth has given okay, correct. Fine. What about others? So same thing, we are going to write x plus 3 will be equal to capital A into differentiation of our denominator expression, that is 5 minus 4x minus x square plus constant B. We'll just see for two more or three more so that I'm sure that you guys got the way of solving this question. And if anyone has any doubts, you can let me know. Okay, Siddharth has given capital A and capital B values. So minus 1 by 2 and 1. Okay, correct. Perfectly correct. How is integration of 1 by 2? See, for that we have directly applied the formula. So if we are having any integral of format f dash x by root over f of x dx. Right, so here it is in the format of f dash x by root over f of x. Right, so for that directly it will be root over f of x. So that's what we have done. So direct formula which we have used there. So you can just verify the formula. Here it should be either 2 root f of x or root f of x. You guys can check it. So we just directly applied the formula there. So I think the formula will be integration of f dash x by 2 root over f dash f of x will be 2 root f of x, I think. So 2 root f of x plus c will be there. I think you guys can check it. So it's a direct formula application. Okay, I think in the previous one, I didn't kept the 2 root. I just kept f of x. So the previous one, it will be answer 1 by 2 we have written, right? So it will be 2. Here it will be there. So it will be 5 minus 4x plus x square plus 5 sine h inverse x minus 2 by 1 plus constant c. So these two will be getting cancelled. So it will be root of 5 minus 4x plus x square plus 5 sine h inverse. So this will be the answer. So I just forgot to keep the 2 here, because the formula for this will be 2 root f of x, where 1 by 2 will be getting cancelled. So yeah, so that's it. So now you can just we'll be using the same formula here. You can just check it here. So what about the second question solution? Can you guys just verify me the A and B values? Yeah, I have already given the answer here. You can just check it here. So I have written the formula in terms of sine h inverse. So if you guys prefer to write in log, it's up to you. So basically it depends upon the option whether they have given in sine or in terms of logarithmic. Plus 5. Yeah. So only the 2 will be getting cancelled. So what about the next question answer? Anyone? Okay, except Siddharth. Siddharth has already given. So this is our integral. I mean new question. I just changed. So 5 minus 4x minus x square. Just a slight change. So here somebody has already given a value is equal to minus 1 by 2 and b value equal to 1. So I'm sure it's correct. So I'm going by it. So then it will be minus 1 by 2 into our differentiation, right? So here it will be coming. So minus 2x and minus 4 plus 1 divided by root over 5 minus 4x minus x square dx. So after substituting our ax in place of px plus q, if we have substituted that thing, so this will be our integral. So now we can just further simplify it. So it will be minus 1 by 2 integration minus 2x minus 4 by root over 5 minus 4x minus x square dx plus 1. So integration of 1 by root over 5 minus 4x minus x square dx. So these are the two terms which we are having. So you can assume one as I1 and you can take other to be I2, and you can easily find the integral for this. Still any questions in this? Or you guys still solving this one? Can you guys please let me know if you require more time, or else we can just proceed to our next. Okay, got it. So I hope most of you has got it. So here it will be the direct formula 2 root f of x. So in the previous I just missed this too, sorry. So okay, most of you has done. Okay, so now you got the idea how to solve this irrational function. So if we once aware of this irrational functions, the same as the rational which we have seen our previous one. So let's get to the next. So here we are having some specific types of irrational algebraic functions. where you are having the corresponding substitutions and how to solve it further. So here comes the type 1, where you are having the integral of form dx by x minus alpha root over x minus alpha into beta minus alpha. Right, so there your substitution in place of x will be a cos square q plus b sin square q. Right, so similarly for the in the place of same type 1, we are having one more, that is basically in terms of factors. Our type 1 is related to in terms of factors, where the corresponding substitutions are given. If it is in the format of x minus alpha into root over x minus alpha into beta minus alpha, then our substitution is related to sine and cos. And if it's 1 by x minus alpha into root over x minus beta, then our substitution is related to secant and tan. Right, so if we get into the second type of here, so in the second type, it's not a direct factor, but it is in the format of ax plus b and px plus q. Then in place of this root expression, we are going to substitute t square and we are going to further simplify it. Right, so similarly, we are having a type 3, where we are having the expression, the integral of format 1 by ax plus b into the root of a quadratic function, that is an algebraic function here, that is px square plus qx plus r. So this is in one variable, so linear in one variable, this is quadratic in one variable. Here we are going to substitute in place of ax plus b, we are going to substitute 1 by t. So I know in integrations we'll be having a lots of substitutions and lots of standard integrals which we have to remember. Yes, but while doing it again and again, you'll be familiar with all these. So don't worry, but it will be coming by practice only. So you have to look into all the types daily so that it will be a practice for you and you won't be getting confused with this identities and the substitutions and the standard integrals and all. So the only thing here we are having these many standard integrals is actually to reduce our time, because you can see the standard integrals which we have seen, those are nothing but in terms of root over x square plus a square, x square minus a square, but actually those integrals we can actually solve it by using our substitution method, but we don't want to waste our time by doing that substitution method and all. So that's why we are just remembering them as a standard integrals. Right, so here comes our type 4 expression, which is a format. So here the quadratic form is outside and the linear form is inside the square root. So whether it's inside the square root or outside the square root, we are going to take px plus q only. So here if it's outside, then it will be 1 by t, and if it's inside, we are going to take it to be t square, because here our aim is to eliminate the square root term. So if I take it to be t square, then my square root will be eliminated here. So for the next, both are quadratic. Right, so here you can take one of the quadratic term and you can assume it to be a t square, whatever is present in the square root, and you can simplify it. Right, so these are the some substitutions, are very basic substitutions. So here we'll just try and solve one simple question related to this types of substitutions and all. So here you can see the first format, which is in terms of dx by x plus 1 into root over x minus 2. So we can get back here and you can observe which type which actually falls in, and you can pick out the corresponding substitution quickly. So you can identify which in which type it will be falling. So you can go by type 2 also, or you can go by type 1 also, because here they are having a and b as a coefficient. So there is a possibility that that can be 1, because here in terms of trigonometry, it's a huge substitution. Yes or no? So instead of preferring that huge substitution, we can pick it a easier substitution. So that's why I suggest you to take this type 2 substitution for this following question. So where you can identify our A and P values are 1 here. So mostly we'll be going by type 2, type 3 and substitutions only. So type 1 it's very rare because it's a huge substitution in terms of sine, cos and all. So that's why, that's the reason. Yeah, Arun, it's type 1 only. But even if you observe, it falls in type 2 also, where our P and A values will be 1. So it's up to you, you can go by anything. But I prefer to go by type 2 because it's a simple substitution, right? So where in terms of the square root expression, we are going to substitute t square, which is the easiest one comparatively to our previous type. So go by type 2. So we'll be preferring what will be the easiest way to solve. So that's the way we have to pick. So comparatively, our type 2 will be the easiest way to simplify this question and get the answer. So because it will be directly eliminating our square root, right? So that's why you can directly follow by our type 2. So according to type 2, whatever the expression is present in the square root term, so that will be assumed as t square. That means here x minus 2 will be assumed to be t square. So further you know how to simplify it so quickly. So because if we do it, we can directly eliminate the square root expression. So did anyone got the simplified version of this integral, or else did anyone got the direct answer? You can just let me know. Or any doubts, any questions? Okay, Arun, done. Good. So what about others, guys? So here we have assumed, we have substituted x minus 2 is equal to t square. Then what will be our simplification? If I differentiate this, dx will be equal to 2t dt. Right, so dx will be equal to 2t dt. So let's substitute that here. So in place of dx, I am going to substitute 2t dt. And in place of root over x minus 1, I am going to substitute t square. And in place of x plus 1 also, we can substitute in place of t. Yes or no? So how can we do that? So x minus 2 is t square. Right, so x minus 2 is t square. So in place of x plus 1, what you are going to substitute? So plus 1 and minus 1. So it will become x plus 1 minus 3. Right. So in place of x plus 1, we can substitute t square plus 3. Right. So now I am going to do that. So here it will be t square plus 3. Because my entire thing to be converted into in terms of t. So here in place of x minus 2, I have substituted t. So corresponding place of x plus 1, I am going to substitute t square plus 3. So if I reduce it further, it will be 2t dt by t square plus 3. So here root expression, so it will be t. So this t and this t will be getting cancelled, and I'll be remaining with 2 dt divided by t square plus 3. 2 is a constant, so which can be pulled out. So 2 integration of dt by t square plus 3. Right. So now if you observe t square plus 3, so which is according to in present our standard integral format. So let's convert that into our standard integral form. Right. So it will be 2 integration of 1 by t square plus 3 dt. So now to convert this into standard integrate form, what I am going to do? So 2 integration. So this can be written as 2 square and 3 can be written as root 3 whole square. So into dt. So now this is in the format of x square plus a square. So 1 by x square plus a square. So that expression will be 2 into 1 by a, that is 1 by root 3. So tan inverse x by a, that will be x will be t by a here root 3 plus c. But here we can't leave it in terms of t. So it will be converted into again in terms of x. So 2 by 3 tan inverse. So in place of t, what can we substitute? That is our x minus 2 by root 3 plus c. It will be under root because we have substituted t square, right? So it will become square root. Okay, Shivaranjani, Shyam. Okay, everybody got it. So this will be our final answer. So the integral here will be equal to 2 by 3 tan inverse. So I can put it as a whole root. So it will be x minus 2 by 3 plus constant c. So this will be the final answer for this integral here. Right. So this is about our type. So based upon the type, whatever they have given, we can correspondingly observe which will be the simplest way to solve it, and then we can follow the procedure. So now we are just moving into our next type of functions, which is nothing but our trigonometric functions. Right. So in this trigonometric functions, we are having different types. So today we are just going to start with the first type of trigonometric functions. So here comes the first type of trigonometric function. So in this, so any integral of form dx by a plus b sine square x. Right. So if any integral is of form dx by a plus b sine square x. So where a and b are any real values. So it can be any real values. And the second form of this type 1 is dx by a plus b cos square x, which means here it can be either a sine function, that is sine square x, or else it can be either a cos function, that is cos square x, or else it can be a combination of both sine and cos functions. So our type 1 here will be completely discussing about our trigonometric functions sine and cos in different formats, in different categories, in different special functions. Right. So the first form here you can observe, it will be dx by a plus b sine square x, or else in place of sine square x we can substitute, it can have a cos square x. Right. And the third form here, it can be a combination of both sine and cos functions, which is dx by a cos square x plus b sine x cos x plus c sine square x, or else it can be of another form, that is our fourth form, dx by integration of, so it's a complete integration, so a sin x plus b cos x whole square. So our type 1 involves 4 different forms of functions of our, which is inclusive of our sine and cos function here. So now the thing is, if our function, if any trigonometric function is falling in this typical type 1, then how we'll be going to solve this corresponding special trigonometric function of type 1? So that's the question. So can you guys have any idea? So far we have solved many substitution questions, many standard integrals. So can you guys think of any solution? So how can we start solving this type 1 special trigonometric functions? So by looking at the each of the form, can you guys think of any way? Any ideas? If you're having any ideas, you can please let me know. It can be new, something new also, but still it can give you the answer. So basically, they will be having a different ways to simplify any of the form, but we are going to follow the easiest way, the simplest form to get the answer, because in exam we won't be having that much time to spend the whole time in our one single question by doing a trial error. So we can start with this method, if not we can work it on with other method. So that much huge time we won't be having while doing our examination. So that's why the whole thing here is we have to consume our time, we have to utilize the given time, and we have to simply solve all the questions in the given period of time. So here the thing we are going to use is, so the condition here is we are going to divide the both numerator and denominator by the term cos square in all these such type of integrals, right? So and then if we divide with all the terms with cos, we'll be having some will be eliminated, will become 1, and some terms will be becoming as sine by cos will be becoming as tan, right? So there is a pause. In these types of forms of trigonometric functions, they will be converted into tan. So where in place of tan x we are going to substitute t. So someone has suggested we can use cos square formula. Yeah, it's up to you. You can use that also, because in our trigonometry we have seen our formulas, so you can apply that also, but there might be a chance it will be a bit lengthy, or else sometimes we cannot get the answer. So yeah, so it's the type 1. So for any of these forms of type 1 special trigonometric functions, our solution is to divide the complete expressions, that means both the numerator as well as the denominator, by the function cos square x. Then our entire function, entire integral will be turning out in terms of tan function, right? So that will be turning out in terms of tan function, and then in terms of tan x we are going to substitute t. So let's see for one thing how it will be turning out to be. So let's see what about our first case. So if we are having dx by a plus b sine square x, so we are going to divide with cos square x, so it will be 1 by cos square x divided by, so a by cos square x plus b sine square x by cos square x integration dx. So what is 1 by cos square x? That can be written as secant square x divided by, here also a secant square x plus b tan square x, right? Which means our entire form of trigonometric function will be turning out to be in terms of tan, and when we differentiate tan we'll be having again secant, so that means it will be complete turning out to be from sine function to tan and secant function. So this is our first type of special trigonometric function. So there are few more types, I guess 2 more types are there in this special trigonometric functions. So those 2 types we'll be discussing in our next session, and we'll be doing questions related to this special trigonometric functions also in our next session. And after this special trigonometric functions, we are going to discuss about exponential function, and with that we'll be finishing our indefinite integrals. And at the end of this session, in our next session, I'll be trying to add the recent 2020 mains level questions. If any question is from this indefinite integrals chapter, I'll just pick it up and I'll just add into our next session, so that we can have you guys can have an idea of what will be the level of a JEE mains, exact JEE mains level questions, right? So that's all for today. So I hope you guys are clear with it. So we'll just continue the trigonometric and the rest of our indefinite integrals in our last session along with the JEE level questions. So thank you guys. We'll just continue in our next session.